12.6, do our vocab. Compound events. How do those work here? So, we've done some compound events here, such as, well, we've done singular events. All the we haven't figured out probability of compound events though. We've made some trees. We figured out total outcomes. We use counting principles. So compound events are events that have two or more events that, how do they call it there, are considered a single event. So we're going to be figuring out probability of compound events here. And again, the probability we've done has all been singular things here. Pick a tile of this, pick a marble from the bag of that. You know, we did experimental, theoretical, odds. But these were all just singular events here. Compound events would again be like flipping a coin and spinning a spinner. Two or more things here, and then I could say, well, if I roll the dice and flip the coin, what's the probability of getting a heads and rolling a 2? So multiple things going on here. We know the probability of flipping a heads is 1/2, theoretical. We know the theoretical probability of rolling a 2 is 1 in 6. So what's the theoretical probability of rolling or flipping both the heads and rolling a 2?
1 in 12.
Yeah, it would be 1 in 12. And essentially what we're going to do is multiply. We're going to figure out the probability of each event independently and then multiply those fractions essentially together to figure out the compound probability. So breaking it down a little further here, dependent and independent here. So independent events, what happens with one event has nothing to do with the other event. How would the book say it? The occurrence of one event does not affect the probability or likelihood that the other event will occur. I like my definition better. So, independent events in the situation we just talked about the coin and the rolling a dice, that would be independent events, because whatever would happen with the coin, whether I get a heads or tail, has no bearing whatsoever on what's going to happen when I roll the dice. They're independent events of each other. There's no, whatever one outcome is, has no bearing on the other outcome. Dependent events, you can probably guess what the definition of this is going to be. What happens with the first event affects, or affects maybe, whatever one you want there, who knows. It's not ELA, so pick your A or E for that word. What happens with the first event affects the probability of the next event. And we haven't gone through really any dependent events yet this year. So examples of this would be if, say, I got 5 marbles in a bag, 3 red and 2 blue. And I pick a marble out, and then I leave it off to the side, and then I pick another marble out here. So just for example here, we'll just look at this as independent and dependent, and then we'll switch over to notes in just a minute. So I'll say 5 marbles, 3 red, 2 blue. So if this was an independent event, and I say pick a marble, put it back, pick again. What is the probability of getting a red and then another red marble? Okay. So I'm saying pick one, put it back, pick again.
Wait, we go to notes.
Not yet.
Okay.
And what is the probability of getting red, red? So the first time I pull out a marble, what is the theoretical probability of me pulling a red marble out?
3 and 5.
3 and 5. Right, so I'd write that down here. Now, I'm going to multiply that. And again, so I've picked a marble, put it back in the bag, shake it all up again. Now, when I pick again, what's the probability of me picking a red marble?
3 and 5.
3 and 5, because I put the marble back in the bag. It really doesn't change here. So then if I multiply those together, I can't cross simplify anything. 9 and 25, if I did it as a decimal or percent, it'd be 0.36, or I have a 36% chance of pulling a red marble, throwing it back in the bag, shaking it around, and pulling another red marble out here. There's the probability. If it was a dependent event, I would say pick one, do not put it back, and then pick again. So same scenario, probability of getting a red followed by a red.
3 out of 5 and 3 out of 4.
So first, you were right, 3 out of 5. Nothing's changing because there's 5 marbles in the bag, and 3 of them are red. Now, when I pick the second marble,
Oh,
though,
you 2 over 4.
that's exactly right.
Yeah.
Because consider, I'm not putting the marble back in the bag. So how many marbles are in there? Well, now there's 4 marbles in the bag because remember, I pulled my red marble, I'm not putting it back. So when I go back in the bag, there's 1 less marble in there, 1 less red marble. We're assuming I've picked a red marble here the first time, putting it aside. So then, how many of the marbles, which marble did I take out? I took out a red marble. So how many red marbles are left? 2. And if I multiply that, I get 6 over 20, simplified 3/10. And of course, you can see the probability of that happening is going to go down because, as you would expect, the second time when I pick a marble, one of my winners is no longer an option for me anymore. It's sitting next to the bag. So the likelihood of me getting another red marble is reduced. Same scenario, one more, and then we'll move on to notes. But what about red, red, red?
Oh, no.
So independent, what would that look? You guys set it up real quick on your own. What's the independent probability of getting red, red, red? And then what's the dependent probability of getting red, red, red?
You just want in like fractions, right?
What does it say here? Pick one and pick, use formula. Yep, fractions here. What does it say? Use formula if I'm right. Yep, fractions. On the back side here, it says write the probability in decimal form, round to the nearest hundredth. So for now, fractions is fine. I just wrote it this way so you can kind of see the percentages, but you should understand that if there's 1 less winner in the bag that second time around, that the likelihood of that happening is going to decrease. If I set a red and then a blue, well, the likelihood of that happening in a dependent event would increase, because if I pull out a red marble first, well, now there's 1 less marble, which means there's a better likelihood of pulling a blue the second time.
What would happen if there's like not 1 Wouldn't it just be the 0 over something?
Yeah, you won't be asked that type of question. These will be things that, yeah,
We have
that would
those
be
on-
0. Yeah, obvious. Yeah, if
That
it
was
said,
on the homework.
huh?
Number 8, it's green then purple.
Green, then purple here. Well, yeah, that's going to be 0. 0
Yes.
is the answer to that one there. As soon as you run into something that's impossible, multiplying anything by 0 is 0. And that's exactly what you would do here. There's a probability of green, but purple is 0 over, and multiplying by 0 always equals 0,
Alright.
which puts it smack dab in impossible. So, anyway, what do you guys think? What's the independent of red, red, red? 18 over 175?
I got 27 over
125? 27 over 125?
Yep.
One of those. So I'd have 3/5 times 3/5 times 3/5. So 3 times 3 is 9. 9 times 3 is 27. 5 times 5 is 25. Times 5 is 25. So 27 over 125 it would be.
I think I multiplied the 9.
You must have did 9 times. Yeah, you must have did 9 times 2 maybe.
No, I think I did the 3 times 3, but I think I accidentally added it.
Oh, that could be 3 plus 3 plus 3 is 9 times 2. So 27 divided by 125. Probability of getting red, 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 if I keep putting it back, is 21, about 21.5% of that happening there if I keep putting it back. So now, what if I don't put it back? What's the probability of that? You two.
1/10, yeah.
1/10. 3/5 times 2/4. And then the third time, now there's only 3 marbles left in the bag.
And one of them is right.
Right, so 3 times 2 is 6 over 60, 1/10, or about a 10% chance of that happening. Well, exactly 10% chance. No, not impossible. This is about 21.6%. This is 10%, so each time I take out one of those winners, the likelihood of me drawing another red marble is going to decrease each step of the way from 60% down to 50% down to 33%. So by this point here, 2 of the 3 are blue marbles at the last stage here. So to pull all the reds out here, again, not likely, but also not impossible. So 10% is not particularly likely to occur. So anyway, think you got it? Great. Okay, let's go over the notes there. Again, the main key is, again, trying to keep track of what type of event is going on here. Really, the key thing you'll be looking for is if you do not replace something, whatever that may be, a tile, a marble, something like that. If you do not replace it, then you're talking about a dependent event. But if you replace it, or if the things have absolutely nothing to do with each other, such as flipping a coin and rolling a dice, well, that's independent. One has nothing to do with the other at all. The probability of those two events doesn't change. Doesn't matter which one I do first. Matters not. So, I guess question 3, ditto with 2 and 4, it's just labeling, are these dependent or independent type events here. So number 3, picking Jim's name from a hat first, then picking Judy's name second to determine teams for gym class. So what do you guys think? Is that an independent or dependent type event? Yeah, dependent, because again, the order matters here. Jim's name can't be in the hat for Judy to go, and then picking Judy second. So we'll pull Jim, put him aside. Judy would have to come out second there.
I don't think there's anybody in school ever currently named Judy and Jim.
even in my years of subbing, I didn't run into really anybody with those names that I think of off the top of my head.
Mr. Jim is the only one I can think of.
Those are diabolical.
I'm gonna name my kid Judy, just for
No,
that.
no.
Judy.
No.
Cause then if you're still working here.
Tootie Judy. Duty Judy. Judy Tootie. Duty. Duty. Right. That's probably why Judy's no longer popular. Rhymes with duty.
Dim Jim.
Right. Dim Jim.
Slim Jim.
Slim Jim.
Slim Jim.
Rim Jim.
Don't know what I mean.
Glim Jim.
I just, Glib Jim.
I think Dim Jim and Slim Jim would be the bigger ones there.
Prim Jim.
Needs to go to the gym.
Jim's
Jim
Jim.
Jim.
Is there a place called Jim's Gym?
Probably.
Probably. We could Google it to figure out where the nearest Jim's Gym is to us.
Jim's Gym.
I'm certain one will come up
I
on
want to go to
Google.
Jim's
for it.
Gym.
We'll check that in a minute. Anyway, yeah. So there you go. All right, find some probabilities here. John has a drawer containing 2 blue pens, 2 red, 2 orange, 2 green. Picks 1 pen from the drawer, does not replace it.
No.
Then picks a second. What's the probability of getting a green, then orange? Two blue, 2 red, 2 orange, 2 green. Picks 1 pen, does not replace it. Then picks a second pen. Give everybody their moment of the shine here in class for the camera.
No camera.
Future years should watch this. They'll be awed by your brilliance.
We're so smart.
Right, okay, all right. So you can just give me the simplified if necessary here. Eve, what do you think? 1/14 is correct. So, again, probability of green, you go, well, how many greens are there? There are 2. And how many pens are there? Well, there are 8. So there's the probability of getting green. And then it says orange, but of course, it specifically says do not replace it. So we're assuming I've picked a green pen first and it's now out. So goodbye green, that's 1 less pen. But how many oranges are in there? There are 2 oranges. The pen that's missing is a green pen. So if for whatever reason it would be green then green, of course it would be 2/8 times 1/7 in that scenario, but almost anything else, this is how it would be. Basically, it's the same question as number 5. It's just blue then red. So there's the blue and there's, of course, red. Still 2 reds in the bag, so 456. Or you can just cross simplify here and here. And then I could simplify 2/4 to 1/2 if you so choose, but wherever you get there, as always, 1/14 is what it shall be. Easy enough. All right, number 11, pretty much the same deal here. Mary has a drawer containing 3 blue, 4 red, 1 orange, 2 green, picks a pen. Later, without replacing the pen, so does not replace again, dependent event, she picked a second pen from the drawer. So now, what about getting a red then blue? Same setup generally, just different numbers of things. Total outcomes is different, number of ends is different, but I feel like you guys are understanding this
Mr.
here.
Walker, are we cooking?
Yeah, I feel like we are. Feels like it's going pretty smooth. All right. Well, got it locked in here. All right. As always, you can simplify me. Sam, what do you think in the end there?
2/15.
2/15 is correct.
Yeah.
So 2 things I need to know. How many red pens there are? There are 4. And how many total pens there are? 7, 8, looks like 10. When you're doing these, I mean, if you want to write it, you can simplify your fractions to do your math part here if you want to. That's fine. Whatever works for you. And then, of course, then blue. So now, of course, there's 9 pens left. Not replacing that red pen. How many blues are there? There are 3. Or I could simplify that too this way. I mean, you either get 12 over 90, divide each of those by something, or 2 over 50, divide by 6.
Oh, yeah.
That's actually what it would be. So when you're doing your math, again, I don't really care if you write them unsimplified, simplify at the end. But these fractions for your math, you can simplify them right away if you so choose. All I really care about is in the end, you got 2 over 15. However you want to get there is up to you. But personally, I tend to write simplified fractions. I mean, if I can just simplify these right away, I just do it for the math part. Just smaller numbers are always easier to work with. But totally up to you guys what you want to do. 2 over 15. Good with that? Great. All right, 13, make a table. All right. 14, draw a tree diagram to show all the different outcomes here. There's not that many of them here.
Are these,
I'll give you a different scenario here, and you can just build your tree diagram. So this is an either or, like earlier. You can build a table or a tree diagram for this kind of stuff, so I'll just...
come in.
Yeah, the door's probably locked. So I'll give you a different scenario here. Hello, dear. Oh, it's Selena's.
We're doing G is for go get donuts.
Oh, well, I like that there.
You
Wow,
got one for your dog?
I am good. Boy, the probability of me getting a donut, 1 over 1.
What's that?
My probability of me getting a donut, 1 over 1.
Right,
Or 100%.
100%.
Oh, that's so good. Oh my gosh.
Why do you
That
have to
is
eat
good.
it, one of us?
Man, G-Day is the best. I tell you what. You know.
Oh, it's more like
Oh my gosh.
I'm gonna confiscate that.
I'll cut some donut off for you guys here in a minute. What's that?
Guys, sit down, behave.
Share the
Sit down,
donut.
look forward, Colin.
We'll share the donut 5 ways
Yes.
once we're done here. Anyway, I'll create another little spinner here. So when you do it, I guess just build a tree diagram of the or a table, whatever you want to do here. So I'll just do a spinner like this. I'll say 1, 2, 1, 3. So what are they telling us to do here? Joe spins the spinner, then flips a coin. So I'll say spin the spinner, flip a coin. There's my coin. Pretty
That's a
impressive,
field
huh?
looking coin.
That doesn't, I don't think that's how coins work.
So
You're my coin. You might wanna get that.
draw a tree diagram or build a table. How many total outcomes are there here?
This is an independent event, right?
Yes, it would.
I forgot how to write numbers. I keep writing my ones as keys.
Well, I'll give you a hint. You don't add a line on the top.
Well, I do.
So they're showing 2 different things here. And again, I won't ask you anything quite like this, but showing the total number of possible outcomes is one thing. Showing a diagram of all the different outcomes is a different thing. Because some of the outcomes are going to repeat. So therefore, they're not necessarily different.
Oh.
So 2 questions. How many total outcomes are there? How many different outcomes are there? They're different answers.
The things I got.
Sorry, what?
How many total outcomes are there? How many different outcomes are there? So when you build your tree diagram, you'll realize that some outcomes are the same. So count those each as 1, because how many different outcomes are there?
Oh.
Like if the same event could happen twice, specifically with this situation here, those the same outcome. So how many different outcomes are there?
Oh, okay. I was very confused.
Since we have so few problems here, I'll save that so we can do 17 and 19 here. So,
What?
your last two sticks. So anyway, if I build a tree diagram showing total outcomes, anybody have an idea how many total outcomes we got?
8 total,
Run.
6 different.
1, 2, 3, and then a heads, tails, heads, tails, heads, tails, heads, and tails. Total outcomes.
I did it the other way around.
Yeah, that's fine.
There's
You can do
6
tails,
different outcomes,
heads,
just
1, 2.
another-
Yeah, that's fine too. If you did it this way, you still get, yeah, no problem with that. Both are fine, doesn't matter. But 8, and then different outcomes would be pretty much exactly the same, except without that, how many different outcomes are there? There are 6, because this outcome is repeated here. One's heads and one's tails can occur twice. So, I don't really care what you do with 14, just do something. Either draw a tree diagram, there's either 10 outcomes or 6, depending if you represent it total or different. So, whatever you want to do, I don't care. Draw a tree diagram, got it? Represent either different or total. If you want to show both, even better. Okay, got it, great. Last two, for my last 2 sticks. So here we go again. This time we got leaves. Picks a leaf, guess what? He doesn't replace it. And then he picks another. Who would have thought? So now, write the probability in decimal form rounded to the nearest hundredth. So you should figure it out as a fraction, yes. And then I hope we know how to turn fractions into decimals, and I hope we know how to round to the nearest hundredth. But figure it out in fraction form, just like you did earlier. Take your final answer and convert it to a decimal rounded to the nearest hundredth. Picking an oak, then not maple. So, a little bit of thought there.
Okay, I just completely timed it out a little bit.
So an oak first, and then not a maple.
Then not a maple. Oh, my.
Right. So not oak, then maple. It's oak, then not maple. So after you pull out your oak, how many of them are not maple leaves left in the bag?
We will never know.
Well, we will really know. We will know. I like that. Well, I guess we'll never know. It's kind of like number 8, I guess. That one we'll never really know.
Mr. Mosh, wait, what's number 8? Oh, that.
Number 8?
It's the one with 0.
Why do they give us problems like that?
It's because they're mean.
They're not scared.
It's because they're bad people who enjoy torturing
They're
people.
like,
Holy moly.
You guys are really moving the pencils around on this one here.
I'm done. I'm just looking at number 20 because I want to see how to do it.
I'm just like,
We want to fill the cup anyway.
Well, it looks like Eve and Sam are sitting out. So,
Yay!
so it's down to you two. One of you gets this one, the other gets 19. So. All right.
Okay.
17. You can just give me the decimal here. Faith, what do you think?
Almost done.
She's almost done there. Don't you have a calculator, Faith?
I don't know.
Why don't you just borrow my calculator, Faith? It's not a problem at all to give you a calculator.
But I'm almost done.
Well, you're totally entitled. You can always have a calculator. We'll always let you borrow one. Faith's doing it by hand, so,
That's unfortunate.
well, she's increasing her division skills, I suppose.
I don't think I've done long division since like chapter like 4.
16 over
No, I don't want to do 19.
105.
What?
16 over 105.
16 over 105.
That's not a decimal.
then
Well, that will help you out. That's what you think it is. 16 divided by 105. So 0.15 you're going with?
I got 1.5.
1.5. You take 16 divided by 105, right?
Oh wait, yeah, it is 0.1.
Right, 0.1. It's okay.
I didn't get that.
I didn't get that.
Me neither.
I
Well,
got 0.1.
so let's see.
0.7.
Well, we
I
don't
got
even know if that's
0.07.
right or not here. So, first off, what is our probability of getting the oak leaf? Anybody?
4
4.
over 15.
Over 15, then I don't want to count. Right, 4 over 15. So there we go. Now, what's the probability of not getting a maple?
9 over 14.
8 over 14.
Well, there's 14 leaves. Which one did we take out?
The maple.
No, we took out the oak.
Oh, yeah.
So there's 3 oaks plus 5 birches. There are 8.
Oh, okay.
Because the one we took out is the oak leaf. We want not maple.
Oh, I
So
didn't take
the
that.
second
Okay, I see
poll,
what I did.
remember, an oak leaf is out. We pulled the oak leaf out first,
That's what I
right?
did.
So then when we go back for the second time, there's 1 less oak leaf in the bag. So there's 3 oaks and 5 birches. So this, you are correct. It is 8 over 14. There's 1 less leaf, but the missing leaf is an oak leaf. Or not a maple leaf is the one. So that's the one we took out here. Does that make sense? Okay. And then, yeah, you can cross simplify 2 and a 7, but 16 over 105, that's exactly what she told us there, and she was 100% correct. Yeah, well done, Faith. Nice job. Nice work on that one there.
Nice one.
Really good.
Me too.
So, again, you get to, or 32, what's 15 times
It did not
14?
click in my little
You could
brain.
just do, you got your calculator, you can just do 32 divided by 210. And again, rounded to the nearest hundredth. Looking at that third decimal, that's telling me am I rounding up or down. 2, of course, is round down or stay the same.
My little brain did not
1500s.
click that 4 and 14 can be cross simplified.
That's okay. Again, you can just multiply 32 divided by 210 is the same thing as 16 divided by 105 too. So with your calculator, it's, you know, we're not representing it as a fraction anyway. Ultimately, we're turning it into a decimal. So cross simplifying isn't really necessary for this situation because this is what we
Oh,
wanted
wait,
in
never
the
mind.
end
We still
here.
have 19 to do.
Right.
Colin, that's you.
Okay. Unless I put everybody back in the cup
Yes.
randomly.
Please,
No,
please,
no,
please.
No.
Or we could do 21 too.
No.
Ooh. The challenge.
Let's not do that. Let's just keep calling it.
Like it. What if that's your extra credit question on the test?
Why are we drawing a tree diagram?
For
Okay, you're
what?
given 5 cards.
Is that what we gotta do? You are given 5 cards numbered 1 through 5. You select a card, do not replace it, and select again. Draw a tree diagram. You don't have to draw the tree diagram. Find the probability of getting a 2 and then a 5. Probability.
Okay, here we
Don't
go.
draw the tree diagram.
Just give me
Just figure out the probability, okay? So you got 5 cards, 1 through 5. You select a card, you do not replace it, you draw again. What is the probability of getting a 2 followed by a 5?
Sam can have it.
No.
This is not a over.
Back to you.
If you don't get it, you get no donut.
Ah, if I don't get it
Oh.
right, or if I don't,
Oh, that would raise
If
the
you just
pressure.
can't answer.
That would raise the pressure.
If
Come on, Colin, you got this
You're
here.
gonna
Colin,
Got
not
this.
got this. I want more donut.
I don't want a piece of bite taken out of it. don't
I was gonna cut that piece off for myself,
What are we
so
gonna-
Ah, yeah, we're gonna cut it with
I'll get a knife.
the box cutter.
It sounds
I'll
like
get a
breast music.
knife.
I'm not gonna go.
You're annoying.
Let's use the electric saw.
Maybe like spikes.
Donut crumbs for all. Yeah, that would be.
I sometimes the video was doing that.
Just shred the donut and make a huge mess along the way. Just there's no winning
Yeah, where is
outcome.
the saw?
Colin, you think you got it for
Okay,
us?
Maybe. Oh, that's not
What's the probability of me pulling out the 2?
1 over 5.
I like that.
Yeah,
And then,
Skip.
if I don't replace the 2, what's the probability of me getting the 5?
1 over 4.
Uh-huh.
Yeah!
And if I multiply
Okay,
those
no.
together, Colin,
1 over 20.
there you go.
Yay!
Ding, 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 ding.
That wasn't hard.
Feel good about it?
Yeah,
Yeah.
like and
Alright.
subscribe.
Don't have-
Thanks, Faith.
It looked
Oh,
harder than it really was.